Good morning, everyone. Today, I'm going to explain the concept of perceptron. This is the continuation of the previous lecture, perceptrons and machine learning. Let's move on the next slide and let me discuss about the perceptron, how the perceptrons are working. So, in machine learning, we already discussed perceptrons are considered as a single layer neural network that has four main parameters which I already explained in my last video. As the input value and also inputs are called as nodes, weights, bias, net sum and activation function. The perceptron model begins with all input value with their associated weights. Then add these values together to create a weighted sum. This sum is applied to the next layer called activation function, which is represented as small f to obtain the desired output. The activation function is also known as a step function and this can be represented by small lowercase f. This is a perceptron model in machine learning where you're seeing is the number of input nodes starting from x1, x2, x3, or you can number it like 1, 2, 3, 4, 5, associated with its weight w0, w1, w2, w3, and uh, all these two things are added together. You will get a net input function. Then it goes to the activation function. As we discussed earlier in machine learning, we have a different types of activation function like sine, step, sigmoid function. So only one difference we have here in this network architecture compared with the previous, the basic perceptron model is here you can see the back propagation network, which means that before going to the final layer, that is the output layer, if any errors are present in the activation function. What is this activation function? To mainly used to check the neurons are fired or not, which means like the neurons are burnt, neurons are properly processed, or it is performing the function or not. If suppose any errors are there in this particular layer, what we do, we will back propagate the same input back to this particular node, that is after assigning the weight. So we will rectify back, this is the concept called back propagation network. So here we will find out the error detection and error correction also will be done over here. Then the new weight and input value will be assigned. Then again that will be added together to net input function, then goes to activation function, then the proper values will be sent to the output. This is the perceptron rule. I think the only difference here compared with the basic model of the neural network is it has a feedback path. We can say it's a feedback path, or we can say it is a back propagation network. Whenever you find any error in the activation function, the values will be back propagated and it is rectified and again giving back to the activation function. This is one of the advantage here in this model. But moving on to the detailed explanation about what is happening in each and every layer. The first step, input values are added with their weight in order to determine the weighted sum mathematically. And we have the calculated weighted sum, summation of, that is summation, right? Summation means adding together the input along with the weight multiplied with its weight, xi into wi, x1. So xi is sum of all the inputs. So what are the sums? X1 into W1 plus X2 into W2 till you have Xn into Wn. Then add a bias value B, a special term B, to its weighted sum to improve the model performance. So finally, we have got the equation from the step 1, summation of Wi into Xi plus B. In step 2, we are going to perform the activation function, which is applied with the above mentioned weighted sum, which gives the output in the form of binary values, and it has a continuous values y equal to, this is y is represented as the activation function, which is equal to function of f of summation wi into xi plus b. So So this is the output values after the step 2. In uh, after step 2, then directly it goes to the output layer. Okay. Types of perceptron model based on these perceptrons are divided into two types: single layer perceptron model and a multi-layer perceptron model. The single layer perceptron, which has only a feed forward network, it has only one layer, so it is called single layer, right? So it has only a feed forward network. It also includes a threshold transfer function inside the model. The main objective of the single layer perceptron is to find out or analyze separate linearly separate object with the binary outcome. The next is next type is multi-layer perceptron model. We have two stages: multi-layer, which from the name we can say it has a multiple layer perceptron. Okay, which has two stages, which executes in two stages: forward stage, and the other one is the backward stage. What is this forward stage? The activation function, it starts from input, then it moves to forward and it terminates on the output. But backward, like the feedback, in the backward stage, weight and bias are modified as per the requirement, and error between the actual output and demanded originated backward, that is, it is sent back, and the new weight and input values are assigned, then it transmitted to the output layer. So these are all the two types of layers present in the architecture. Perceptron function. How this perceptron is functioning? F of x is used to denote the perceptron function, can be achieved by multiplying the input x with a learned weight coefficient w. So mathematically we can express it as follows: f of x is equal to 1. When you multiply w into x plus b, that is this term you know, right? Weight associated with this input x plus the bias b should be greater than 0. Otherwise, f of x will be a 0. Okay, activation function will be 0. So, which means that the neurons are not fired. There is no data are processed in the network. Right? So, w represents real weighted values, b represent bias, and x represent a vector of input values. So, there are some of the basic characteristics of perceptron. Is a machine learning algorithm for supervised learning, mainly used in binary classification. Perceptron, the weight coefficient is automatically learned and weights are multiplied with input values. Then the decision is made whether the neurons are burnt or fired. Activation function applies a step rule to check whether weight function generates 0 or greater than 0. The linear decision boundary is drawn, enabling the distinction between two linearly separate classes. Either it falls on +1 or -1. Then the added sum of all input values is more than the threshold value. It must have an output signal. Otherwise, there will not be any output. These are all the important characteristics of perceptrons. Thank you.